Nvidia's Isaac Robotics platform. Executive summary. Nvidia Isaac is a comprehensive robotics platform that uses artificial intelligence to develop autonomous machines. It features Isaac Sim for realistic virtual testing and Isaac Lab for robot learning. The platform includes Isaac ROS for advanced perception and Project GR00T for humanoid development. By bridging the sim-to-real gap, Nvidia allows developers to train robots safely in digital environments. These technologies now power advanced systems in manufacturing, healthcare, and construction industries. Article: Robots once lived only in science fiction movies. Today, they work in our factories and warehouses. Nvidia Isaac is a powerful platform for developing these machines. It provides the brain and the training ground for modern robots. This platform uses artificial intelligence, AI, to make robots smarter. Developers use it to build, train, and test autonomous machines. The virtual training ground, Isaac Sim. Building a physical robot is very expensive. Testing a robot in the real world is also risky. A robot might crash into a wall during a test. It could break its expensive sensors or arms. Nvidia solved this problem with Isaac Sim. Isaac Sim is a high-fidelity simulation tool. It creates a virtual world that looks exactly like reality. This world follows the laws of physics. Gravity pulls on objects correctly. Friction makes surfaces slippery or grippy. Scientists call this a digital twin. A digital twin is a virtual copy of a real-world space. Robots learn in this virtual space first. They can practice a task thousands of times in a second. This method is much faster than real-world training. It also saves a lot of money. Developers can reset the simulation instantly if the robot fails. Teaching the robot, Isaac Lab. Robots need to learn how to move their joints. This process is called robot learning. Isaac Lab is the specific part of the platform for this task. It uses a technique called reinforcement learning. In reinforcement learning, the robot receives a reward for doing something right. It receives a penalty for making a mistake. The robot tries different movements to maximize its score. Over time, it discovers the best way to walk or grab an object. Isaac Lab handles many robots at once. It can train a whole army of virtual robots simultaneously. This massive scale speeds up the learning process significantly. Seeing the world, Isaac ROS. A robot must understand its surroundings to move safely. It uses cameras and sensors to see. Isaac ROS provides the software for this vision. ROS stands for Robot Operating System. It is a standard set of tools for robot builders. Nvidia added special AI models to Isaac ROS. These models help robots recognize objects. They can tell the difference between a person and a box. The software also helps with navigation. Navigation is the ability to move from point A to point B. The robot creates a map of the room as it moves. It identifies obstacles and plans a path around them. The mind of the humanoid, Project GR00T. The most exciting part of Nvidia's platform is Project GR00T. This project focuses on humanoid robots. Humanoid robots have 2 arms and 2 legs like people. They are very difficult to program. GR00T acts as a foundation model for these robots. Think of it like a base level of intelligence. It helps the robot understand human language. You can tell the robot to pick up the blue cup. GR00T translates those words into movements. It also helps the robot imitate human actions. A robot can watch a video of a person and learn the same task. Real-world applications. Many companies use Nvidia Isaac today. These robots perform many different jobs across various industries. Industry, robot task, manufacturing, moving heavy parts on factory floors, healthcare, assisting surgeons with precise movements, logistics, sorting and carrying packages in warehouses, construction, operating heavy machinery with voice commands. In 2026, We see these robots everywhere. Surgical robots use Isaac to move with extreme precision. These machines help doctors perform complex spinal surgeries. Delivery robots use Isaac to navigate busy city sidewalks. They avoid pedestrians and traffic without human help. Moving from sim to real. The biggest challenge in robotics is the sim to real gap. A robot might work perfectly in a simulation. It might fail when it enters the messy real world. Real-world lighting changes throughout the day. Real floors have dust and bumps. Nvidia uses domain randomization to fix this. The simulation changes the colors and textures of the virtual world. It adds noise to the robot's sensors. This variety prepares the robot for the unpredictability of reality. When the robot finally moves to hardware, it is ready. The hardware. Jetson Thor. Software needs a strong engine to run. Nvidia created the Jetson Thor computer chip for robots. This chip fits inside the robot's body. It provides the massive computing power needed for AI. Jetson Thor handles the robot's vision and thinking at the same time. It consumes very little power for its size. This efficiency allows the robot to work for many hours. Without these chips, robots would be slow and clumsy. Conclusion. Nvidia. Isaac is changing how we build machines. It combines simulation, AI models, and powerful hardware. This platform allows robots to learn like humans do. They learn by practicing and observing. We no longer need to write every line of code for a movement. We simply provide the environment and the goal. The robot figures out the rest. This technology makes robots safer and more capable. It brings us closer to a future where robots help us every day. Here is a comparison of the primary modules within the Nvidia Isaac platform. Nvidia Isaac platform module comparison. Module, core function. Primary use case. Key features, Isaac Sim. Simulation, building digital twins and testing. Photorealistic rendering, PhysX physics engine, and synthetic data generation. Isaac Laboratory, learning. Training robot movements, AI policies. High-speed reinforcement learning, support for humanoid robots, and joint control. Isaac ROS perception. Helping real-world robots see and move. Hardware-accelerated vision, object detection, and 3D mapping, SLAM. Isaac Perceptor. Navigation, autonomous movement for mobile robots. Obstacle avoidance, 3D occupancy grids, and path planning for warehouses. Isaac Manipulator. Manipulation, controlling robotic arms and grippers. Precision grasping, motion planning, and 6D pose estimation for objects. Project GR00T. Humanoid AI. Developing general-purpose humanoids. Foundation models for reasoning, language understanding, and movement imitation. How the modules work together. Developers rarely use just one module. Instead, they combine them into a single workflow, design. You create a 3D model of your robot in Isaac Sim. Train. You use Isaac Lab to teach the robot how to walk or pick up tools. Deploy. You move that intelligence onto a physical robot using Isaac ROS for vision. Execute. The Jetson Thor chip runs these programs inside the robot's body. Note, the platform uses OpenUSD, Universal Scene Description. This format allows different 3D tools to share data easily. It ensures that a robot looks and acts the same in every software module. Do you have trouble finding information in your company? You know it's in there somewhere. You just can't find it. Search fails when you use the wrong keywords. You can't ask questions like you can with Chrome or Edge. I can help you solve that problem. Contact me for a free 30-minute consultation. If you get value from these blogs, please consider joining my Patreon as a member at the $2, $4, or $8 level. https://www.patreon.com/Steve Hovland.